Welcome to the video lesson for slant asymptotes. A slant asymptote is going to happen anytime the degree in the numerator is greater than the degree in our denominator, and the denominator does not cancel out. To find the slant asymptote, we are going to go through the process of using long division. And we're going to perform this after we have canceled out anything with our numerator and our denominator. For our first example, let's go ahead and make sure that we know we're going to have a slant asymptote. I look at my numerator and I see that my degree is 2. I look at my denominator, I see my degree is 1. So this is going to be our third situation where the numerator has a larger degree. To go ahead and find our slant asymptote, again, we're going to go and use long division, but first I want to verify that nothing's going to simplify or cancel out. And when I look at x squared plus 2x minus 8, that can factor. We have x plus 4 and x minus 2. But then when I look at that in my denominator, I have x minus 1, and nothing is going to cancel out there. So now I can go ahead and do some long division. I'm going to go ahead and write my x minus 1 on the outside. And then we're going to have x squared plus 2x minus 8 on the inside. I'm trying to get my first set of terms to be the same, so I'd like x to be the same as x squared. So the question is, what do I have to multiply x by to turn it into an x squared? And we're going to be multiplying by an x. So we're going to multiply by x, and then we get x squared minus x, and we now subtract that. When I subtract x squared minus x squared is going to cancel out, and then 2 minus a negative x is going to become a 3x. We're then going to go ahead and bring down our 8, and now I'm looking at my x and my 3x. I want those to be the same, so to make them the same, we're going to go ahead and multiply by a 3, and that's going to get me 3x minus 3. And then we're going to subtract. When we subtract, 3x minus 3x is going to cancel. And then negative 8 minus a negative 3 becomes a minus 5. Now for the equation of our slant asymptote, this minus 5 is a remainder. And we're going to just ignore that, which means that the equation we're going to end up with is what we have on top of y is equal to x plus 3. For our sign diagram, we're going to approach that the same way we've been approaching it. We're going to look at our vertical asymptotes and also our x-intercepts. And looking at our factored form, I definitely know I'm going to have a vertical asymptote at 1. And then I'm going to have an x-intercept at negative 4 and at 2. When I go ahead and perform my sign diagram and I plug in values within my intervals, plugging in the negative 5 is going to give me a negative value. If I plug in, let's say I plug in a 0 into my function, I get negative 8 over negative 1, which is going to be positive. If I plug in something between 1 and 2 into my function, I'm going to be getting a negative value. And if I plug in something greater than 2 into my function, I'm going to be getting a positive value. All right, we're going to go ahead and graph our asymptotes now. My first asymptote was that vertical asymptote at x is equals to positive 1. And then I now have to graph my slant asymptote, which is y is equal to x plus 3. Going back to our slope-intercept form, I know I can graph that by starting at 3 and then going up and over 1 to create some points that's going to be on that line, or down and left 1. And then we have our slant asymptote. I also know that I have some intercepts. I have an x-intercept at negative 4. I have an x-intercept at positive 2. And I know that by looking at my numerator. Okay, we're going to go do some sketching now. To the left of negative 4, my function is negative. That means it's below the x-axis. To the right of negative 4, it is positive. That means it's above. So we're going to follow along our slant asymptotes, go through our intercept, and then we're going to slant up. And then looking at my right side of my vertical asymptote, I know I start negative, I go through my intercept of 2, and I become positive. So we're going to have something that looks like this, and this creates our graph for that slant asymptote. We're now going to go ahead and look at how do we do our limit notation. Everything is the same. The only difference is we have to kind of modify how we talk about the limit notation with our slant asymptote. But looking at our function, we can quickly write down the limit notation for our vertical asymptote, and then also if we had a hole, we could talk about that as well. But let's look at this vertical asymptote. I know it's going to be where x is equal to 1. And I know that on the left side of 1, something is happening, and on the right side of 1, something is happening. If you look at the left side, it is going to be going up. That is this region over here. As we follow along, we see that it's definitely going up. So that means that our limit is going to be going to positive infinity. If you look at the right side, Again, we're going to trace our function. I see on the right side of that vertical asymptote, it's definitely going down. So I know that my limit is going to be going to negative infinity. All right, we do not have another vertical asymptote, so we can ignore that one for now. We also do not have a hole because we didn't have a common factor that would cancel out, so we can ignore that as well. And now for our slant asymptote. Our slant asymptote is going to replace the behavior of our horizontal asymptote, but the notation is going to kind of start the same. So to describe the limit notation for our slant asymptote, just like for our horizontal asymptote, we're going to be looking at n behavior, which means we're going to start with the limit as x goes to negative infinity, and then we also have the limit as x goes to positive infinity. Now, initially, the n behavior would level off around your horizontal asymptote, but now we have to figure out for our slant asymptote if the function is going up or down, similar to your vertical asymptotes. So I see that on the left side, or as we go to negative infinity, it's definitely going down, which means that my function is going to be approaching negative infinity. And I see that on the right side of my slant asymptote, it's going up. So that means that my function is going to be approaching a positive infinity. So again, for our slant asymptotes, it's replacing the n behavior that we used to use our horizontal asymptote to identify. And now we have to figure out if the slant asymptote is going up towards positive infinity or going down towards negative infinity. Let's go ahead and look at another example here. Before we jump into our example, we're going to go ahead and modify this a little bit. We're going to make this negative 3a minus 6x instead. So now we have 3x cubed plus x squared minus 2x over 2x squared minus 6x. The first thing we're going to do is we're going to look for a common factor here to see if we have a whole. I'm going to take an x out of my numerator, and I'm left with 3x squared plus x minus 2. And if I take an x out of my denominator, I'm left with 2x minus 6. And that tells me that I definitely am going to have a whole because these x's are going to cancel. I also notice that the degree from my numerator is squared, whereas the degree from my denominator is to the first power. So this also tells me that I'm going to have a slant asymptote as well. We're going to approach this the same way we approached the previous example. We're going to go ahead and start by doing long division to find our slant asymptote. I have 2x minus 6, and we're going to divide that into 3x squared plus x minus 2. Our goal when we're doing long division is to make our first set of terms the same. So I'd like this 2x to be the same as a 3x squared. In order to do that, we're going to multiply by 3 over 2x. And when I do that, I'm going to get 3x squared minus 9x. And then we're going to go ahead and subtract. When I subtract, I know that my x squares are going to cancel. X minus the negative x is become a 10x. And then we bring down this minus 2. And now we're going to go ahead and try to make our 2x the same as a 10x. In order to do that, we're going to multiply by a 5, which gets me 10x minus 30. We're going to go ahead and subtract. Our 10x's are going to cancel, and then negative 2 minus negative 30 becomes a positive 28. Again, that positive 28 is a remainder, which we do not care about in terms of our slant asymptote. And our equation is what we have on top of our long division of y is equal to 3 over 2x plus 5. When I look at my expression over here on the right side, I want to be able to find my x-intercept, so we're going to factor our numerator. Again, that was a 3x squared plus x minus 2. That's going to factor as 3x minus 2 and x plus 1. And then for my denominator, we can factor out a 2, but I know that it's not going to cancel out, so we're going to leave it like that. But I know now that I'm going to have x-intercepts at 2/3 and negative 1. And looking at my denominator, I know that I'm going to have a vertical asymptote at 3, so that helps me to set up my sign table. Again, I know that I have an x-intercept at negative 1. I know I have an x-intercept at 2/3. And these are from setting my numerator factors equal to 0. And then I know that I have a vertical asymptote at 3. To fill out our sign diagram, we take values in these intervals to plug into our original function. If I were to plug in something like negative 4 into my function, I'm going to get a negative value. So I know that it's negative for the function. If I plug in, let's say, a 0 into my function, I know I get a positive value. So this is going to be positive. If I plug in something between 2/3 and 3 into my function, I get a negative value. So I know this is negative. And if I plug in something bigger than 3, I know I get a positive value. So we're going to make this positive. We do have a hole here, so we want to make sure that we identify our hole as well. I know that because my factor of x canceled, I have a hole when x is going to equal 0. If I plug 0 into my function, then I get the corresponding y value, 1/3. Okay, we're going to go ahead and graph our parts here. I know that I have an intercept at -1. I have an intercept at 2/3, so it's going to be right around here. And I have a vertical asymptote at 3. I also know that I have a hole when x is equal to 0 of y equaling 1/3, so that's going to be right around there. And then for my slant asymptote, it's 3 over 2x plus 5. So when I go to sketch that, I'm going to start at my y-intercept of 5. We're going to go up 3 and over 2. Or I can go down 3 and left 2. Do that again. And now I have my asymptote. I can extend this one a little bit as well. Looking at my sign table, I know that to the left of -1, it is negative. To the right, it's positive. And then to the right of 2/3, it's negative. So this basically tells me I have a parabola. So I'm coming from the negative side, I'm now positive, I go back down, and that helps me to sketch out what I see in between my slant asymptote and my vertical asymptote. So again, we have this negative to a positive, and then back down to a negative again. And then I know that to the right side of my vertical asymptote, it is only positive, so that means that it's going to be in the section up here. For our limit notation, now again, we know that for the vertical asymptote and the hole, it's the same as it has been. We're going to go ahead and approach that. I know that for my vertical asymptote of x is equal to 3, the limit as x approaches 3 from the left side, we see that it is going down. Again, we're on the left side of 3. My function is definitely going down, so then my value is going to be a negative infinity. And then we see that on the other side, as we're approaching 3 from the positive, our limit is going to be a positive infinity because it is definitely going up. All right, for our second vertical asymptote, again, there is not a second one, so we can cancel that out. Our hole, this time we do have a hole, and the limit for our hole is always going to be approaching its corresponding y value. So for both the left and the right side, we're going to be approaching that value of 1/3. So you have the limit as x approaches 0, because that's where our hole is from the left side, is going to equal 1/3. And then we also have the limit as x approaches 0 from the right side. It's going to be 1/3 as well. And then finally, for our slant asymptote, again, that is going to be replacing the horizontal asymptote to help us describe our end behavior. So we're going to start with the limit as x goes to negative infinity. That would be the left side. And the limit as x goes to positive infinity. That would be the right side. So looking at our function on the left side, I see when I go to negative infinity, it is going down, which means that the function is also approaching negative infinity. And I see that on the right side, it is definitely going up, so that my function is approaching positive infinity as well. All right, let's go ahead and give you a chance to try an example. Okay, so now it's your turn. Go ahead and try this example. I would suggest you first take out any greatest common factors, and then factor to see if anything cancels to give you a whole. And then from there, find your slant asymptote using long division, and then try to sketch your function with the rest of the information and fill out your limit notation. Go ahead and hit pause now, and then try this problem, check back in. All right, let's see how you did. So to begin with, we want to take out a GCF for both the numerator and the denominator of x. And if we do, we see that we're left with x squared plus x minus 12 over 2x plus 2. I notice that my degree in my numerator is 2, degree in the denominator is 1, so I know I'm going to have a slant asymptote, so I jump over here to do my long division. When I go through the process of doing long division, I'm left with y is equal to 1/2. Again, this negative 12 is our remainder, which we don't need for our slant asymptote. So then just y equals 1/2 is the slant asymptote. When I go back to my function, if I factor my numerator, I get x plus 4 times x minus 3. So setting each one of those factors equal to 0 will help me identify my 2x intercepts. Looking at my denominator of 2x plus 2, setting that equal to 0 will give me x equals -1 for my vertical asymptote. And then because I had those x's cancel, I know I have a hole when x is equal to 6. And I have a hole when x is equal to 0. And if I plug in that 0, I get -6 for my actual value. So this is now the location of my hole. When I go to set up my sign diagram, again, we're including our x-intercepts and our vertical asymptotes. And I see that on the left of -4, it's negative. Then we have positive, and then negative and positive. So we're going to go ahead and graph our information. I have my slant asymptote graphed here. I have my vertical asymptote. I place my points for my intercepts and then also for my hole, and I'm going to use my sign diagram. I know that -4 is an x-intercept. I also know that 3 is an x-intercept, so I'm going to be below the x-axis, and then I'm going to cross through the intercept and become above my axis, and that's what we see happening here. Again, we're below, crossing through our x-intercept, and now going up. And then for our other side, I know that I'm going to again be below because it's negative. I have my hole, and then I cross through my x-intercept, and I start to increase on the other side, staying along my asymptotes. Looking at our limit information, that is the same as it has been. So for our vertical asymptote, we are going up on the left. Again, we can see we're definitely rising on the left side of -1. We're going down on the right side, so we have f of x going to infinity as x goes to -1 on the left side, and then f of x going to negative infinity as x goes to -1 on the positive side. For our hole, we're going to be approaching that coordinate of -6 from both the left and the right side. And then our slant asymptote, again, that replaces our end behavior. So as x goes to negative infinity, the function is going down. So I know we're going towards negative infinity. And then as x goes to positive infinity, our function is going up. So I know that it's going to positive infinity as well. All right, that's going to do it for our notes. We do have one more question, but we're going to wait and talk about that in class on Monday because this one's going to have 2 vertical asymptotes. We'll make sure that we can talk about that together. But for now, go ahead and try the homework. Good luck, and I'll see you next time.